In this video, we will discuss about different Viva questions and answers with circuit diagrams for BEEE lab brake test on three-phase induction motor. The circuit diagram consists of a three-phase supply as shown in figure RYB. RYB. The voltage between R phase and Y phase is 415 volts, 50 Hz. Three-phase is supply. The voltage between any two phases RY, RYB or RB is 415 volts AC supply, which is connected to TPST switch. TPST means triple pole single throw, which is connected to fuse of 10 amperes. The fuse is to protect the equipment against overcurrents. Here our equipment is a three-phase induction motor, which is protected with the help of 10 ampere fuse in each phase. Now the circuit is consisting of an ammeter, an voltmeter and two wattmeters. Ammeter is rating is 0 to 10 amperes. The type of the ammeter is MI and the voltmeter rating is 0 to 600 volts and the type of the wattmeter is voltmeter is MI, whereas the two voltmeters W1 and W2 both are of UPF. UPF means unity power factor with voltage rating of 600 volts and 10 amperes. The two wattmeters are connected to the three-phase starter winding. In the figure, A1, A2, B1, B2, C1, C2 represents the starter winding of three-phase induction motor. The rotor is connected to a brake drum, which consisting of two spring balances S1 and S2. S1 is weight is in kgs as well as S2 weight is also kgs. Coming to the bio questions and answers. What is a motor? Motor is a machine which converts electrical energy to mechanical energy. What are the types of starters used in AC machines? The starters used in AC machines are DOL starter. DOL means direct online starter, star delta starter, auto transformer starter are the starters used in AC machines. What are the types of three-phase induction motors? There are two types of three-phase induction motors. One is squirrel cage induction motor, other one is slip ring induction motor. What is the principle of three-phase induction motor? The working principle of three-phase induction motor can be explained by considering a portion of it as follows. When a three-phase starter winding is fed from a balanced three-phase supply, a rotating magnetic field is produced in the motor. This RMF rotating magnetic field rotates around a speed called synchronous speed, which is given by Ns equals to 120 F by P. The rotating magnetic field passes through the air gap and cuts the rotor conductors, which are at stationary. Due to the relative motion between the rotating magnetic field and the stationary conductors, an EMF is induced in the rotor conductor. As the rotor is provided with end rings, a current is flows in the rotor conductor. Now, a current carrying conductor is placed in the magnetic field, which will experience a force and rotor starts rotating. This is a principle of three-phase induction motor. It works on Faraday's laws of electromagnetic induction, like a transformer. Here EMF is induced. That's why we'll call this motor is three-phase induction motor. There is no connection between the stator and rotor. The EMF is induced. That's why we'll call this motor is called three-phase induction motor. Now, in the wattmeter, there are four terminals are there: M, L, C, and V. What are the M, L, C, V in wattmeter terminals? M indicates main, L indicates line, C means common, V means voltage. Abbreviate TPST. TPST means triple pole single throw switch. Which type of meters are used in this experiment? Moving iron. MI. MI means moving iron. Explain Fleming's left hand rule. According to Fleming's left hand rule, if we stretch thumb, forefinger, and middle finger perpendicular to each other, the forefinger represents the direction of magnetic field, the middle finger represents the direction of current, and the thumb represents the direction of force. What is slip? It is the ratio of relative speed to synchronous speed, whereas relative speed is nothing but difference between synchronous speed and rotor speed. What is slip speed? It is the difference between synchronous speed and rotor speed. Induction motor principle works on the principle of Faraday's laws of electromagnetic induction. What is the function of star delta starter in induction motor? The star delta starter is used to limit the starting current in induction motor. Brake test on DC shunt motor. The circuit diagram consists of a 220 volts DC supply. Now to obtain 220 volts DC supply, normally we may use a rectifier which will convert a three-phase AC supply to a 220 volts DC supply, which is connected to DPST switch. DPST switch is nothing but double pole single throw switch, which are connected through fuses. The rating of the fuse is 20 amperes. Since the DC shunt motor rating is of 20 amperes, that's why we are placing a fuse of 20 amperes. Now if current is more than 20 amperes, then automatically fuse will burn out and the motor will be protected against overcurrent, which are connected to voltmeter as well as ammeter. The type of the ammeter and voltmeters are MC. MC means moving coil, which are connected to a 3-point starter. Will have R minimum, that is rheostat of rating of 370 ohms by 1.7 amperes. F and FF indicates the field winding, whereas A and AA indicates armature winding, which are connected to the mechanical load consisting of two spring balances S1 and S2. S1 is in kgs and as well as S2 is also kgs. What is the function of starter? The function of starter is to limit starting current. Now, what are the different types of starters? 2-point starter, 3-point starter, and 4-point starters are used in DC machines. What are the different types of DC motors? DC motors are firstly classified into two types: separately excited DC motor and self-excited DC motor. Again, self-excited DC motors are classified into three types: DC shunt motor, DC series motor, and DC compound motor. Again, DC compound motors are classified into two types: long shunt compound motor and short shunt compound motor. The DC compound motors are again classified into two more types. One is cumulative compound DC motor as well as differential compound DC motor. In cumulative compound DC motor, the shunt field winding and series field winding fluxes are added, whereas in differential compound DC motor, the shunt field winding flux and series field winding flux are opposing. Explain the function of no volt coil in 3-point starter. It will shut down the DC machine when there is no voltage. What is the formula for back EMF? Back EMF VB equals to pi Zn by 60 into P by A. where phi is the flux per pole, P is poles, A is number of parallel paths, Z is number of conductors, and speed N is in RPM, and flux phi equals to flux per pole in Webers. Now, if the armature winding is lap winding, the number of parallel paths A equals to P. If the armature winding is wave winding, the number of parallel paths A equals to 2. Explain the function of overload release coil in 3-point starter. It shuts down the DC machine when it is operated at overload. The overload release coil is operated if there is overload. The no volt coil is operated if there is no load. Both are shut down the DC machine only. If a 3-point starter is not available, how can a DC motor can be started? With the help of rheostat placed in series with armature circuit, the DC motor can be started. What is the type of meters used in this experiment? MC. MC means moving coil. Explain Fleming's left hand rule. The Fleming's left hand rule says that stretch the forefinger, middle finger, and thumb perpendicular to each other. Forefinger represents the direction of magnetic field, middle finger represents the direction of current, and the thumb represents the direction of force. Explain Fleming's right hand rule. According to Fleming's right hand rule, stretch forefinger, middle finger, and thumb perpendicular to each other. The forefinger represents the magnetic flux, direction of magnetic flux. The middle finger represents the direction of induced currents, whereas thumb represents the direction of movement of the conductor or motion of the conductor. What is the purpose of brushes? Brushes are used to collect the generated EMF from the armature via commutator in DC generator. Supply the DC power to armature via commutator in case of motor. Brushes are made with carbon. What is the purpose of commutator? Commutator converts AC to DC in case of DC generator, converts DC to AC in case of DC motor. DC generator works on which principle? DC generator works on principle of dynamically induced EMF. What are the parts of DC machine? The parts of DC machine are yoke, pole core, pole shoe, armature winding, field winding, commutator, and brushes. What are the three terminals in 3-point starter? The three terminals in 3-point starter are line, armature, and field. Line is represented with L, armature is represented with A, field is represented with Z. What is the purpose of 3-point starter? The purpose of 3-point starter is used to limit the starting current. What is if the field rheostat must be in dash position? Why? The field rheostat must be in minimum position. If not, the speed will be high and the motor may damaged. Due to this, the field flux is controlled. Load test on single phase transformer. The circuit diagram consisting of a single phase AC supply which is given to the auto transformer. Now the function of auto transformer, the rating of auto transformer is 230 volts by 0 to 270 volts. Auto transformer is also called variac. The supply given is a 230 volts 50 Hz AC supply which are given to DPST switch through fuses. Now the meters used in this experiment are moving iron. MI is the type of the meters and the rating is 300 0 to 300 volts voltmeter rating and 0 to 10 amperes ammeter reading. The wattmeters ratings are 300 volts by 10 amperes UPF. Both wattmeters are of same rating. Here we normally will prefer a one here one you will consider a 1:1 transformer. 220 volts primary voltage as well as 220 volts secondary voltage. There we will connect a load R load. Now you must has to mention the type of the ammeter and voltmeter. Here the circuit diagram which is not mentioned is moving iron MI. MI is the type of the voltmeter as well as ammeters, whereas the type of the wattmeter is dynamometer type. What is a transformer? Static transformer is a static device which transfers power from one electrical circuit to another electrical circuit without change in frequency. What is the principle of transformer? It works on the principle of Faraday's laws of electromagnetic induction and mutual induction principle. What is Faraday's laws of electromagnetic induction? Now, from Faraday's first law of electromagnetic induction states that whenever a conductor is placed in a varying magnetic field, an electromotive force is induced. It is the Faraday's first law. The Faraday's second law states that of electromagnetic induction states that the induced EMF in a coil is equal to rate of change of flux linkages. What is Lenz's law? Lenz's law states that the polarity of induced EMF is such that it tends to produce a current which opposes the change in magnetic flux that produced it. What are the different types of transformer types? What are different transformer types? Based on the construction, there are mainly two types: core type, shell type. There is one more type is there, berry type transformer. Based on voltage, step up transformer and step down transformer. Based on the medium of core used, air core transformer, iron core transformer. Based on the winding arrangement, auto transformer, or second one is two winding transformer. Based on the install location, there are power transformer, distribution transformer, measurement transformer, and protection transformer. Based on the supply, there are single phase transformer or three phase transformer. What is meant by EMF? EMF means electromotive force, is a measurement of energy that causes the current to flow through a circuit. What are the type of meters used? The type of meters used are MI. MI means moving iron. What are the terminals in a wattmeter are? M means main, L means line, C means common, V means voltage. Abbreviate DPST. DPST means double pole single throw switch. Half wave rectifier without and with filter. Now circuit shown is a step down transformer. Whereas input is given of 230 volts 50 Hz single phase supply, which is stepped down to 6 volts AC. The transformer is reduce that voltage to 6 volt 230 volts to 6 volts, which are connected to a diode of IN40001 connected through an ammeter. Rating is of 0 to 200 milliamperes. The output is connected at the 1 kilo ohm resistor either by using a multimeter or by the waveform can be observed in CRO. Expand CRO. CRO means oscilloscope. Now, if we are connecting a filter, we may use different types of filters. The basic types are C section filter, L section filter, LC filter. Now, in C filter, capacitor is connected in parallel to output. This is a C section filter. Now, if we are adding a filter, then the output ripples will be reduced. Means output AC content in the output AC content will be reduced. What is rectifier? Rectifier is a device which converts AC to DC. What is the ripple factor for half wave rectifier? Ripple factor is equals to 1.21. Define ripple factor. It is a ratio of AC content to DC output. What is the efficiency of half wave rectifier? The value of efficiency of half wave rectifier is 40.6. What is PIV of half wave rectifier? PIV of half wave rectifier is VM. Abbreviate PIV. PIV means peak inverse voltage. Define PIV. It is a maximum reverse voltage appear across the diode. What is transformer utilization factor for half wave rectifier? Transformer utilization factor equals to, for half wave rectifier is 0.286. Define transformer utilization factor. It is a ratio of DC output to the peak value of secondary of transformer output. Is form factor of half wave rectifier. The form factor of half wave rectifier is 1.57. Full wave rectifier without and with filter. Now here in the circuit, here we are having a center tapped transformer. Primary is of 230 volts, 50 Hz AC input, whereas secondary we are having 3 terminals. The secondary will have 3 terminals, which consisting of 6, 0, 6. Now which are connected to two PN junction diodes IN4007 connected to an ammeter to 0 to 200 milliamperes ammeter, and a resistor is the output. Now their output can be collected through either multimeter or a CRO. CRO means cathode ray oscilloscope. Now here we will placing a capacitor filter of value 1000 microfarads, which are connected at the output, DC output, across the 1 kilo ohm resistor. Now what are the different types of full wave rectifiers? There are two types: full wave rectifier with center tap transformer, full wave rectifier with bridge circuit. Now we are performing the experiment on full wave rectifier with center tap transformer. Now what is the ripple factor for full wave rectifier? The ripple factor for full wave rectifier is 0.48. Define ripple factor. It is the ratio of AC current into DC output voltage. What is efficiency of full wave rectifier? Efficiency of full wave rectifier is 81.2%. What is PIV of full wave rectifier with center tap transformer? PIV of full wave rectifier with center tap transformer is 2 Vm. 2 Vm. Define PIV. It is the maximum reverse voltage appear across the diode. What is transformer utilization factor for full wave rectifier with center tap transformer? Is 0.693. What is the form factor for full wave rectifier, which is equals to 1.11? Comparison of wave rectifier full wave rectifier with center tap transformer and full wave rectifier with bridge circuit. Number of diodes in half wave rectifier is 1, whereas in full wave rectifier with center tap transformer we need 2, whereas in bridge circuit we need 4. The DC voltage or average DC voltage, average output voltage is Vm by pi in case of half wave rectifier. In full wave rectifier it is 2 Vm by pi. In bridge circuit also you will have 2 Vm by pi. The peak inverse voltage for half wave rectifier is Vm, whereas for full wave rectifier is 2 Vm, whereas in case of bridge circuit is Vm. Since we are using center tap transformer, in full wave rectifier with center tap transformer the peak inverse voltage is 2 Vm. Ripple factor for half wave rectifier is 1.21. For full wave rectifier with both circuits, center tapped as well as bridge circuit, its value is 0.48. Rectifier efficiency is 40.6 in case of half wave rectifier, whereas in case of full wave rectifier and with bridge circuit its value is 81.2. Transformer utilization factor is for half wave rectifier it is 0.286. For full wave rectifier it is 0.693, whereas for bridge circuit is 0.812. Form factor for half wave rectifier is 1.57, whereas for full wave it is 1.11, for bridge circuit also it is 1.11. Verification of KCL and KVL. KVL. The circuit consisting of a battery of 15 volts which are connected to two series connected resistors R1 and R2. R1 is of 220 ohms and R2 is 470 ohms. Based on the circuit, and number of elements, we may consider 2 elements or 3 elements or 4 elements. Then based on the number of elements, we need to connect number of voltmeters. That may be 1, 2 voltmeters or 3 voltmeters or 4 voltmeters based on number of resistors. The each voltmeter rating is 0 to 30 volts. Kirchhoff voltage law. Kirchhoff voltage law is a Kirchhoff's second law. It deals with conservation of energy around a closed circuit path. Kirchhoff voltage law states that the algebraic sum of all the voltages around any closed loop in a circuit is equals to 0. State voltage division rule. Voltage division rule is only applicable for series circuits. It states that voltage across any element is equals to total voltage multiplied by that resistance divided by that resistance plus adjacent resistance. KCL. KCL circuit consisting of a battery which are connected in series with an ammeter. It will measure the total current flow through the circuit, and here there are two resistors are given. That's why connected in parallel to two resistors R1 and R2. If you are having 3 or 4, then based on there are maybe 3 branches or 4 branches which are connected in series with an ammeter. Ammeter rating is 0 to 200 milliamperes. State Kirchhoff current law. KCL is Kirchhoff's first law that deals with conservation of charge entering and leaving a junction. Kirchhoff current law states that the total current entering a circuit junction is equal to the total current leaving the same junction. Or in other words, the algebraic sum of all the currents at a junction must be equals to 0, as summation of I in is equals to summation of I out. State current division rule. Current division rule is applicable for parallel circuits. It states that the current flow through any element is equal to the total current multiplied by opposite resistance divided by that resistance plus opposite resistance. PN junction diode characteristics. Coming to forward bias. Forward bias is considered if positive is connected to p-type material and negative is connected to n-type material, or positive is connected to anode and negative is connected to cathode. Now in the given circuit, which is connected, positive is connected to p-type material and negative is connected to n-type material, or positive is connected to anode and negative is connected to cathode through a resistor of 1 kilo ohms and an ammeter. The ammeter will measure the current flowing through the 1 kilo ohm resistor or current flowing through the diode, whereas the voltmeter we will connect, which is connected in parallel to the diode of 0 to 20 volts voltmeter reading, and 0 to 200 milliamperes is the ammeter reading. In the forward bias characteristics, the current is 0 to 200 milliamperes. Since the forward current flows is milliamperes, we will use a 0 to 200 milliamperes ammeter. Whereas in reverse bias characteristics, the battery is reversed, negative is connected to anode and positive is connected to cathode. At the same time, the current, reverse bias current, is in microamperes. That's why we are placing a 0 to 200 microamperes ammeter. Along with, we will change the resistance to 1 kilo ohms to 10 kilo ohms. The diode is connected in parallel to of 0 to 20 volts. Define p-n junction. When a p-type semiconductor metal is suitably joined to n-type semiconductor, the contact surface is called p-n junction. What is breakdown voltage? It is the minimum reverse voltage at which p-n junction breaks down with sudden rise in reverse current is called breakdown voltage. What is knee voltage? It is the forward voltage at which current through the junction starts to increase rapidly. For silicon, V0 equals to 0.7 volts, and for germanium, V0 equals to 0.3 volts. What is the current flowing through the diode? The current flowing through the diode is given by ID is equals to I0 into e power V by eta Vt minus 1, where V is the applied voltage in volts, I naught is reverse saturation current in microamperes. T is the absolute temperature of PN junction in kelvins, and K is the Boltzmann's constant, which is 1.38 into 10 power minus 23 joules per Kelvin. See, the formula for Vt equals to kT by Q, where this K is called Boltzmann's constant, not temperature. Temperature is in kelvins. That K is different, and Vt formula is Vt equals to kT by Q, where this K is called Boltzmann's constant and T is called temperature. The Boltzmann constant is 1.38 into 10 power minus 23 joules per Kelvin, and Q is nothing but charge, electron charge, which is equals to 1.6 into 10 power minus 19 coulombs. Transistor CE characteristics, input characteristics. Now in this circuit, a transistor, an NPN transistor of CL100S is connected in common emitter configuration. Emitter is grounded. Base emitter junction is considered as input junction. Collector emitter junction is considered as for output circuit. Now base junction, base emitter junction is forward bias. Forward bias, the voltmeter what you are placing is VBE of rating 0 to 20 volts. A positive is connected to p-type material and negative is connected to n-type material, whereas input is in forward bias condition. We will place one resistance of 220 kilo ohms. Since the current flowing in base circuit is IB is the base current, which is in microamperes, that's why we are placing 0 to 200 microamperes. For plotting input characteristics, input voltage versus input current. Input voltage is VBE, input current is IB. By making output voltage constant, output voltage is VCE will make constant. First of all, we will consider it 0 volts. Then by increasing the VCC, we will increase the VCE to 5 volts. Then again we will consider draw the characteristics of input voltage versus input current. Output characteristics. Output characteristics are drawn by considering output voltage, which is nothing but VCE, and output current. Output current is called collector current IC. Since the collector current is more current compared to base current, which is in milliamperes, that's why we are placing 0 to 200 milliamperes ammeter. Output characteristics are drawn between collector current IC and VCE voltage, collector emitter voltage VCE, by considering different values of base current. First of all, the base current is here 20 microamperes. Then again we will increase the base current to 40 microamperes. Then we are plotting the characteristics for output voltage versus output current. For amplification, CE configuration is preferred. Why? The CE configuration preferred. Why? Because of following benefits: high voltage gain, medium input impedance, high output impedance, inverting. It can be used in inverting amplifier, good linearity, and greater stability and thermal stability. That's why we are using CE configuration is preferred. Two discrete diodes connected back to back cannot work as transistor. Why? The doping is the properly done in case of transistor. In back to back diode connections, layers are not connected properly. That's why the back to back connection is not preferred instead of transistor. What is current amplification for CE configuration? It is a ratio of output current to input current. Output current is collector current, whereas input current is base current. It is denoted by beta. and its beta value is always greater than 20. It is in between 20 to 500. Most of the transistors are NPN transistor, not PNP. Why? Since NPN transistor, electrons are the majority carriers. Since electron movement is more efficient than the holes, NPN transistors are preferred compared to PNP transistor. Zener diode characteristics and Zener as voltage regulator. In forward bias characteristics, Zener diode across the Zener diode will place one voltmeter, which is of 0 to 30 volts voltmeter. Since the Zener current is in milliamperes, we will place an 0 to 200 milliamperes ammeter in series with an kilo ohm resistor connected to a battery. When positive is connected to anode and negative is connected to cathode, the Zener diode is in forward bias condition. Coming to reverse bias characteristics, negative is connected to anode and positive is connected to cathode, then the Zener diode is in reverse bias characteristics. The forward bias characteristics are same for normal diode and Zener diode are same. There is only difference in the reverse bias characteristics of a Zener diode. What is Zener diode? How it is different from an ordinary diode? A Zener diode is heavily doped with a doping concentration of greater than 10 power 8 in both P and N regions, whereas an ordinary diode has doping concentration of 10 power 17 or less cubic meter or inverse cubic meter cube or less. Explain concept of Zener breakdown. Zener breakdown is occurs because of high electric field. What is avalanche breakdown? Avalanche breakdown is occurs because of collision of free electrons with atoms. What are the advantages of Zener diode? Less expensive than other diodes, high performance standard, protection from over voltage, ability to regulate and stabilize circuit voltage, greater control overflowing current, usable in smaller circuits. State reason why an ordinary diode suffers from avalanche breakdown rather than Zener breakdown. A general purpose diode is lightly doped, so it suffers from an avalanche breakdown rather than a Zener breakdown. What type of biasing must be used when a Zener diode is used as a regulator? It is typically operated in the reverse bias mode. If impurities in the Zener diode is increases, what happens to the forward voltage? If impurities is added in a Zener diode, increases the forward Zener voltage will be low because of thin depletion region, or we can consider the forward voltage drop remains relatively consistent. Verification of Ohm's law. Circuit consisting of a battery is connected through an ammeter of rating 0 to 200 milliamperes and a resistor. Now based on the resistor value, we can now based on the circuit and based on the question, we will consider the resistor. Now here we are considering a 330 ohms resistor, which is connected in parallel to a 0 to 30 volts battery. For if your high resistor value is different, obviously the ratings, the values of voltmeter and ammeter ratings will be changes. Define voltage and give its units. It is the electromotive force which drives the charge flow in a conductor and is measure of potential difference between two terminals. Or it is the work done to bring a charge from an point to another point. Potential difference. It is a work done to bring a charge from one point to another point. Its units are volts. It is represented with V. Define current and give its units. The rate of flow of these charges is called current, which is represented with I. The unit of current is amperes. and is represented with A, and it can be expressed as dq by dt, where q is the charge, t is the time. I equals to dq by dt. I equals to dq by dt, where q is the charge and t is the time. Define power. The DC power is defined as the product of voltage and current. It is produced by the fuel cell, battery, and a generator. The unit of power is watts. P equals to V multiplied by I. The power delivered by the resistor is given by P equals to VI equals to I square R, which is equals to V square by R. Energy lost in the resistor is given by I square RT or V square by R into T. Define resistor and resistance. Resistor is an element which opposes flow of electrons. Resistance is a property of resistance by virtue of it which opposes flow of electrons. The symbol is as shown in figure. It is represented with R. The units are ohms, and where R equals to rho L by A, where rho is the resistivity and the units are ohm meter. L is the length of the conductor and A is the cross-sectional area of the conductor. Define inductor. An inductor can be defined as the energy storage device which stores energy in form of magnetic field, and the units of inductance is henries. Define capacitor. Capacitor can be defined as an energy storage device which stores the energy in form of electrostatic field. Given the symbol and the units for capacitance is farads. Unit for capacitance is farad. State Ohm's law. Ohm's law states that temperature remaining constant, the current flowing through the conductor is directly proportional to the applied voltage. I is directly proportional to V. The different types of electrical elements: active and passive elements, linear and non-linear elements, unilateral and bilateral elements, lumped and distributed elements. And active elements. An active element is capable of generating energy. Examples are voltage source and current source. Define passive elements. And passive elements are capable of absorb the energy. Examples are resistor, inductor, and capacitor. Define linear elements. An element or a network which obeys Ohm's law is called a linear network. Characteristics which passes through the origin is also called a linear network. Examples are resistor, inductor, and capacitor. Define non-linear elements. An element or network which does not obey Ohm's law is called non-linear network. Example is diode. Define bilateral network. A bilateral network or a bilateral circuit is one whose properties are the same in either direction. Example is of transmission line. Define unilateral network. A unilateral circuit is one whose properties are the change in either direction is called unilateral element. Example is diode. Define lumped elements. A network in which all the network elements are physically separable is known as lumped elements. Examples are resistor, inductor, capacitor, voltage source, etc. Define distributed elements. A network in which all the network elements like resistor, inductor, and capacitor cannot be physically separable is known as distributed elements. Example is transmission line, which consists of resistor, inductor, and capacitor. Limitations of Ohm's law. Temperature of material varies. This Ohm's law is not applicable. For nonlinear elements, Ohm's law is not applicable. For semiconductor devices, Ohm's law is not applicable. For vacuum tubes and gas-filled valves, Ohm's law is not applicable. For electrolytes, Ohm's law is not applicable. And for fluorescent lamps, Ohm's law is not applicable. Define frequency. Frequency is defined as number of cycles per second. Its units are hertz and denoted by F. Define impedance. Impedance is defined as which opposes the flow of current in AC circuits. Its units are ohms denoted by Z. Define inductive reactance. Inductive reactance is defined as opposition offered by inductance to current flow in AC circuit. Its units are also in ohms and it is denoted by XL, where XL equals to 2 pi FL. Define capacitive reactance. Capacitive reactance is defined as opposition offered by capacitance to current flow in AC circuit. Its units are ohms and it is denoted with XC. XC equals to 1 by 2 pi FC. Define active power. It is a product of RMS value of instantaneous voltage, current, and cosine of angle between voltage and currents. Its units are volts denoted by P equals to VI cos phi. Define reactive power. It is a product of RMS value of instantaneous voltage, current, and sine of angle between them. And its units are in VAR, volt ampere reactive, denoted by Q equals to VI sin phi. Define apparent power. It is a product of RMS value of instantaneous voltage and current. Its units are kVA, kilovolt ampere, and it is denoted with S equals to VI. Define power factor. It is defined as a ratio of active power to apparent power, or it is defined as a ratio of resistance to impedance, R by Z, or it is defined as the cosine of angle between voltage and current. Define form factor. It is defined as the ratio of RMS value to average value, and it is denoted by Kf. Define crust factor. It is defined as the ratio of maximum value to RMS value, and it is denoted by Kp. This is also called peak factor, crust factor, or peak factor. Form factor for sinusoidal wave is 1.11. Peak factor for sinusoidal wave is 1.414. Thank you for watching. Please share and subscribe if it is useful.